Trigonometric functions can also be graphed on a coordinate plane. Recall that graphs of periodic functions have repeating patterns or cycles. The horizontal length of each cycle is the period. The amplitude of a graph of a sine or cosine function equals half the difference between the maximum and minimum values of the function. So we have done a sine graph already, and this is the sine graph. Cosine graph looks very similar to that. Later on we will talk about why a cosine graph looks the way it does. The domain of both of these graphs are all real numbers because you can always have any degree measure and figure out the sine or the cosine. The range of both graphs without any stretches or compressions is -1 to +1 because since you're always dividing by the hypotenuse and the hypotenuse is the longest side, you will always have an answer that is below 1, or if you're dividing a negative number into the hypotenuse, it'll be greater than -1. In other words, between -1 and 1. So the amplitude is 1, and the period is 360 degrees. Every 360 degrees, the pattern will repeat itself in the parent function. Trig functions can be transformed. For the graphs of y equals sine b theta and y equals cosine b theta, the amplitude is the absolute value of a, the period is 360 degrees divided by the absolute value of b. So for example 1, it says we are to find the amplitude and the period of 4 cosine 3 theta. The amplitude is going to be the a value. So this is the a value, 4. So the amplitude is 4. And the period, this is the b value, the 3. The period is going to be 360 degrees divided by that 3, or 120 degrees. So the pattern will repeat itself every 120 degrees. So over to the right, there is a graph of this cosine function. And notice that the period from here to here, if I put that down here on the x-axis, appears to be about 120 degrees from the start to the end. That's the end right there. And the amplitude is 4 because when we look from the center of the graph, the highest value is 4 and the lowest value is -4. 1/2 of the difference between 4 and -4 would equal exactly 4. Find the amplitude and the period of each of these functions. So the amplitude is the a value, and I don't see a number in front of the cosine, which means there's a 1 there, so the amplitude is 1. And the period is going to be, period, is going to equal 360 divided by 1/2. 360 divided by 1/2 is 720, so it is 720 degrees. For 1b, the amplitude is 3. And the period will be 360 degrees divided by 5 for a 72-degree period. In the previous lesson, we did the sine of theta using the unit circle. We are now going to do the cosine of theta using the unit circle. So starting with 0 degrees, 0 degrees being right here, do you recall what value, which x or the y value is equal to cosine? And it is the x value because on the unit circle, every value, every point is in the form of cosine, sine. Cosine is the x value, sine is the y value. So the cosine of 0 degrees is this number right here, 1. So I will graph 0, 1. And then the next one, the special degree measure is 30. And the cosine of 30 is the square root of 3 over 2, which is approximately 0.86. So square root of 3 over 2 is approximately right here. 45 is the next degree angle looking at the unit circle. It is the square root of 2 over 2, which is approximately 0.7. So 45.7 is about right here. 60 degrees would be 1/2, so it's easy enough to graph, so 60 would be about 0.5. And then we have 90 degrees. The cosine of 90 degrees is 0. So 90 degrees, 0 is right here. 120 degrees would be negative 1/2. So 120 negative 1/2. 135 is negative square root of 2 over 2, which is approximately negative 0.7. So about right here. 150 would be negative square root of 3 over 2, which is about negative 0.86. And the cosine of 180 is negative 1, which places it right about here. And if we go around the rest of the circle, this is what the graph looks like. And there are the rest of the points. So when I draw one full cycle here, this is what the cosine function looks like. So you can see that it starts at 0, 1 and ends at 361 because the full period is 360 degrees. If we were to continue to draw this according to the same pattern, so 390 is going to have the same as a 30-degree reference angle. And so it's going to start to drop at this point. 420 has a 60-degree reference angle. So if I look at the 60-degree mark that's on the other side of the graph, you can see that it's going to be right here, and so on. So that is the parent function for cosine. Now we're going to graph using some transformations. So this one is to graph the function y equals 2 cosine of theta, 2 cosine of theta. So we're not going to graph each individual point, but we're going to look at some key points and help you to graph 2 cosine of theta. First thing we're going to find is the amplitude. So the amplitude is the 2, as we learned from example 1 above. And then the period is going to be 360 divided by the b value. And since I don't see a number in front of the theta, the b value must be 1. So that is a 360-degree period. So where does the sine function begin? The sine of 0 is 0. So that means it begins at 0, 0. And 360 degrees later, it should be back there at 0, 0 again when it starts its next period. Halfway between those points is the 180-degree mark, and it is also going to have an x-intercept at 180 degrees, and that is because the sine of 180 degrees does equal 0. If we go back to the unit circle, and we can see that the sine of 180 is the 0 that I'm circling repeatedly here, and that does equal 0. Halfway between 0 and 180, that's when it reaches its highest point. So we go over to 90, which is halfway between 0 and 180. And since the amplitude is 2, its highest point is 2. And then halfway between 180 and 360 is 270. That's when it reaches its lowest point. And that would be at negative 2. So just going those 5 points and knowing that it is a cyclic curve, we're going to go up to the first point, kind of round it off, then down through the x-intercept, round it off down there at the bottom, and then up towards 360, and it continues that same pattern, and that is one full cycle. So when you're graphing sine and cosine, think about this in terms of quarters. If you think about the last lesson when we were talking about how bicycle pedals turn, when we thought about those in terms of quarter turns, do your sine and cosine functions the same way. So one full period is 360 degrees. So the first thing I graphed was the starting point. So there's the first thing I graphed. And then the second thing I graphed was the ending point. Third thing I graphed was the midpoint. The midpoint between the starting and the ending point was 180. And the sine graph is going to cross again the x-axis at 180. And then I graphed the quarter points, the halfway between the halfway mark. So the quarter points, that would be the fourth point I graphed, and this would be the fifth point I graphed. The fourth point was the highest value, and the fifth point was the lowest value. We can do cosine very similar to that. We look for the amplitude, and the amplitude is equal to 1. It's that 1 right there. The period is going to be 360 divided by the b value. The b value in this case is 4. It has a 90-degree period, so it's going to repeat itself every 90 degrees. So it's going to rapidly repeat itself. Now, cosine starts at the highest point. The cosine of 0 is equal to 1. So the first point is going to be located here at 0, 1. And 90 degrees later, it's going to have to repeat itself. So 90 degrees later, it'll be back up to 1. So I will go up here where 90 degrees is, and I will place a point up there as well. Halfway between the starting points, it reaches its lowest point. So halfway between the starting points, it will be at its lowest point. Since the amplitude is 1, it will go down to -1. And then halfway between that point and the starting point and the ending point is when the cosine function crosses the x-axis. So this, and notice I'm going to kind of round it off the top here, is 1 full period right there. So you can see 1 full period repeats itself much faster than 1 full period did up here, and that's because we had a b value of 4. It shrunk down the period. And then if I wanted to do another cycle, I would do the same thing. So at 180 degrees will be the end of the second period. And so halfway between those 2 points, it will reach its lowest point. And then at the quarter points, we'll be hitting the x-axis. So this would be a second cycle. And I can continue to do that pattern as many times as I wish. Y equals 3 cosine theta. So this time our amplitude is 3, and our period will be 360 divided by the b value of 1, which equals 360. Notice on this graph I don't have any x or y intervals picked because you're going to have to try to figure out what would be a reasonable x or y interval. So for the y-axis, we're going to have to make sure we can at least reach up to 3 and -3. So you got a pretty much whatever option you wanted to use. So I'm going to make each 3 blocks equal to 1 unit. Just make sure you label them on your assignment so I know exactly what you're trying to graph. The period is 360, so if we're doing a period of 360, we can make it just as wide as we did on the first graph up here, where I went 360 all the way across, but I'm going to change it up a little bit. I'm actually going to go by 90s every 4 blocks. Let's go by 90 every 4 blocks. So that would be 90, and then 4 blocks later would be 180, then 4 blocks later 270, 4 blocks later 360, and so on. Again, you might choose to do something different, and that's okay. 4 blocks later would now be 540. Okay. So my amplitude is 3. My period is going to be 360 degrees. So since this is cosine, it starts at the high point of 3. And then 360 degrees later, it will be back up to 3. Halfway between 0 and 360 is 180. That's where it reaches its low point. And then halfway between 0 and 180 is 90, and that's where it gets back to the x-axis. Same for 270. So zoom, we make our kind of a wavy little line here, or curve here. So there's 1 period. And if I wanted to do a second period, I don't have quite enough room to do a second period, but I do know it's going to reach the low point at 540 because that's halfway between that and 720. And then 450 will reach the x-axis again. And it will go back up to 630. That's about 630, and then finally goes off the graph. So that is not quite 2 full cycles, but pretty close.